Welcome to the Bayesian Conspiracy. I'm Eneasz Brodsky.
I'm Steven Zuber.
And we have a guest with us this week. John, can you introduce yourself?
Hello, I'm John Wentworth.
First, if you wanted to do any sort of quick bio intro for yourself, if we didn't do that yet.
Well, I'm an independent alignment researcher. I work on technical problems of alignment, mainly working on abstraction. Things like what makes a water bottle a natural sort of object to think about or recognize, whereas, say, the left half of a water bottle is not such a natural object. Why do humans recognize such things as objects? To what extent will AIs recognize the same things or similar things as objects? That sort of question.
Awesome. And you said that you're an independent alignment researcher. Is that paying gig or what's your day job?
Yeah, so I get paid by grants.
Oh, that's awesome.
Mainly from the Long-Term Future Fund recently.
Outstanding.
I'm very happy that sort of thing exists.
Yep.
Yeah, me too.
John, welcome to the show. Over the past 6 months or so, I have been really wrapped up in the coming AI apocalypse and doomerism, and I was delighted, I guess, relieved to see that there is at least some sort of plan somewhere in the Less Wrong post, The Plan, and The Plan update. So I read through those, and I was hoping you could explain some of this to us, because a lot of it was kind of over my head, and even if I don't understand all of it, it's nice to know that there's someone actually doing something about it.
All right. Then the very first thing I should mention is that there are significant parts of the plan which route through things that I am pretty sure are true, but are not things that I think are particularly obvious or legibly true. So I do not necessarily think that you should have much hope for this, depending on what your priors are. But I do, at least.
So there is a plan, and there is 4 steps to this plan. Step 1 is sort out fundamental confusions about agency. Step 2, ambitious value learning, i.e. build an AI which correctly learns human values and optimizes for them. Step 3 was ellipses, and step 4 was profit. So what exactly is a distillation of this plan?
Yeah, so
that is more than those steps.
First, obviously, that plan is a little tongue-in-cheek.
Yes.
And even step 2, I would say I've since updated on. I wouldn't give the same step 2 today. But like the point of it is sort of most of the work is in understanding agent foundations, like how agents work in general, what are the right ways to think of them, and like getting enough general empirical evidence around that to be sure that we actually have the right foundations there. The general idea is that once you've got that nailed down, the rest of the steps are probably a lot less bad, less difficult.
So the 2 things I want to get right off the top before we jump into the actual plan that really caught my attention. Your median time frame is, you stated, 10 to 15 years, and that you think there's a better than 50-50 chance of this working in time. I just wanted to get that out there because that really drew my attention. Are you still standing by those?
Yeah, I do think I still stand by both of those. The 10 to 15 years was a sort of outside view estimate of how long it feels like it would take to nail down agent foundations and actually build an AI that, won't kill us. My inside view estimate was quite a bit shorter than that, based on gut feel of how quickly things seem to be progressing in terms of understanding agent foundations. I personally find that I'm making very quick progress. There's sort of an impression that figuring out agent foundations is hard just based on, for instance, Miri worked on it for 10 years and didn't make all that much progress. But the truth is, for the most part, the people who have worked on it to date were A, very few people, and B, not necessarily directly tackling the most core problems.
Before we go forward, you say agent foundations.
Yeah.
What are agent foundations?
That's a good question. It's sort of a phrase that gestures at a whole cluster of topics. For instance, my work on abstraction is one thing that's in the general cluster of agent foundations. Like, what sorts of abstractions will agents naturally tend to end up using? Other questions are things like, how will agents naturally end up planning? How will agents naturally end up communicating? How will they naturally end up representing the world? General sort of high-level properties of agents. What sort of properties do we expect to see?
And do you think these generalize across all agents?
I would word it as agent foundations is about finding the properties which generalize across all agents. We don't necessarily know in advance which properties those will be, but certainly we expect that at least some will generalize across all agents. The plan is founded on the idea that the things that do generalize across agents are enough to know what we're doing in terms of AI.
I don't want to make the entire conversation a dig into a dictionary, but is agent something that we can quickly define? Because my understanding of anything beyond the technical level of, say, like the book Superintelligence is not something I have any grasp of.
Yeah, so when I'm thinking about agents, first there's multiple sort of levels of agency. The lowest level would be something like a bacterium, or potentially some of today's neural nets, like some RL agents, or RL trained nets that we call RL agents, right? And these sorts of things have some agency properties. They don't have the sort of full-blown general reasoning capabilities of a human, but they do things like optimize themselves or the world around them. They sort of steer the world into a specific set of states that we say they want intuitively. And then we also have more powerful kinds of agents that can do things like self-reflection. Some people will use the term agent to only refer to like the stronger versions that do things like self-reflection or have explicit internal world models or whatever. I don't think it really matters exactly how you use the word. It matters which generalizable insights you can get at each different level.
You have a quote that I pulled out later on, which I'm just going to jump to right now, that you're trying to understand agency systems in general, be it humans, machine learning systems, E. coli, cats, organizations, markets, what have you. Mm-hmm. I'm fond of the saying, which I'm not sure how tongue-in-cheek it is, but I think it's at least somewhat serious, that humans aren't agents all the time. There's lots of times where we just aren't.
Yep.
And I get to thinking, like, is E. coli and markets, are those actually agenty? I don't think they have a model of the world or that they want things at all.
So again, this goes back to the same thing about like there are sort of different levels of agency. Even with an E. coli, there are like clear internal components which model specific aspects of the world. For instance, classic example here, an E. coli undergoing chemotaxis. The E. coli is trying to swim up a chemical gradient. The E. coli has an internal representation of how quickly the concentration of, for instance, a sugar molecule is increasing or decreasing as it swims. And it uses that to decide whether to keep going in the same direction or whether to turn and go some other direction, right? So that's like a sort of bare minimum model of an internal model, quote unquote, that the E. coli is using to make decisions, right? So even at the level of E. coli, we see things like that. Obviously, it's not like a very sophisticated world model. It's not a very complete world model, but it is modeling its environment in like a durable way and using that to make decisions.
Kind of like my thermostat.
Not unlike your thermostat. Yeah. People do sometimes use the thermostat as an example of a thing that's maybe an agent under a particularly weak notion of agency.
That's how I would think about it. ChatGPT is the hot new thing. At least it was a month ago. I'm sure there's the next cool thing out already. In my model of agenthood, it doesn't quite make it. It doesn't want to do anything. It just does stuff.
Yeah.
Am I on the right track? Or
the distinction I would use here is between a system that is doing some sort of explicit internal general purpose search. So like humans, at least when we're acting very agenty, quote unquote, we have this internal model of the world and we have some goal that we're trying to achieve. And we're like thinking about how to achieve that goal based on our internal model. And there's this sort of explicit search process where we're explicitly thinking about how to achieve this explicit goal. The machinery that we're using for that is fairly general purpose in that you could substitute in a different goal and then we would know how to think about this new goal, right? That's something that probably E. coli does not have, probably ChatGPT does not yet have, where there's this sort of general purpose internal search capability, and we're using that to optimize for an explicit goal. At the level of an E. coli, the goals are entirely implicit. The search capability is not general purpose. It's very specialized to doing E. coli things.
Okay, right on. Thanks for beating that horse to death with me. I wanted to make sure that I was on the same page, just because there's a handful of terms that I think are in here that I would know if I was better read, but I haven't. So I assume that was one of them as far as your use case of it.
I'd like this sort of thing anyway, because I imagine probably half our listeners don't know half of these terms.
In the case of agents, like it's not even a problem of not knowing them. It's just that different people do, in fact, use the term to mean different things at different times.
Exactly. You say also near the top that the optimal strategy is basically to spend as much time as possible sorting out as much of this general confusion about agency and alignment as possible. And then when the timer starts to run out, slap something together based on the best understanding we have. You say you expect it would take 18 to 24 months to slap something together. Where do you get the 18 to 24 months thing from?
So this is just like a general sense of how long it takes to execute a software project if you're really doing the engineering well. Slapping something together in the colloquial sense takes like a week typically for a new software project. But in this case, we want to be testing it out as much as we can. potentially doing some non-trivial work in building new things along the way. It's basically a startup. That sort of thing takes typically on the order of 18 months or 2 years to like really get some proper tests done.
If we could, in theory, get something together in that amount of time, if the impression came that, hey, we're running out of time, it's time to start slapping together what we can with what we've got, what would the world look like that would give that inclination of like, all right, people, let's just try to get something working?
The actual answer here is that the right thing to do is not try to tell when it's time. You just like have some people at any given time who are trying to slap something together based on the current best understanding. Just like a side process that you run in parallel.
Okay, perfect. That's exactly what I was thinking. But
like that should not be what most people are working on most of the time.
How often would these split off? Every month? Should someone start trying to slap something together with what we have?
I mean, it depends on how quickly understanding is evolving. For instance, over the past maybe 2 or 3 years, there's been, at like the cutting edge of our understanding of agents, there's been pretty close to zero progress, public progress. So like we wouldn't really need to branch things off very quickly.
Right.
Over the next few years, I think it's going to be much faster. Probably like every 6 months or a year would be reasonable, and it may get even faster than that. I don't know.
Judkowski pointed out that there's no smoke alarm for AI. Is there any chance we'd have that much of a lead time?
So ideally, that's not particularly relevant because you just have teams that are trying to implement the best thing you can do right now at any given time, and then it doesn't matter that there's no smoke alarm. I do basically agree with the point Judkowski's making in no fire alarm.
If we always have people working on the get something to working in the next year and a half or so project, wouldn't we expect to have something working in the next year and a half to 2 years, whether or not we've
of course not.
Figured out?
You have people working on slapping something together with the best understanding they currently have, but that's with the understanding that the best understanding they currently have probably isn't good enough. That's why like the main line is still understanding things better.
Wouldn't it be expensive to have like by the time we're at the 20th iteration, like 20 teams working in parallel?
I mean, you wouldn't have 20 teams working in parallel at that point. The staggering would just be like, eventually, the new stuff is clearly better by enough that it just doesn't make sense to have the old team going. Or it might just be one team that's constantly updating.
Okay. I wanted to jump in onto the major bullet points here, unless, Stephen, you wanted to hit other things first.
No, I think that leads us in great. There was the line that I liked that in order for iterative engineering to be useful, we first need to have a strong enough understanding of what it is we want to achieve in order to recognize when an iteration has brought us a step closer to the goal. It's the kind of super foundational thing of like, we need to know where we're going to know if we're getting any closer to it.
Yeah.
So I think that leads us in really well.
You said that we're fundamentally confused about agency and alignment. And your first question is, what do you mean by fundamentally confused? So what do you mean by fundamentally confused?
2 ways to answer this. One way would be like generally describing fundamental confusion, but I don't think that's the most relevant thing here, although that's more fundamentally correct way to do it. For our purposes here, the relevant aspect is we're fundamentally confused in such a way that we cannot look at 2 trained neural networks and tell which of them is safer. That's just not a thing we can do in general. We don't know how to do that. And if you can't do that, then that's where you can't rely on iterative engineering, right?
Yeah.
I make a change. I cannot, in fact, tell whether this has made the thing safer or made this thing closer to safe. I can come up with some rough proxies, but then like the entire point is that rough proxies fail. That's why alignment is hard in the first place.
That is freaking huge. That seems like the sort of thing that it's really hard to even get a toehold in.
In some sense, yes, but in some sense, humanity has gotten past this multiple times. The pre-paradigmatic stage of any scientific field looks like that. In the very early days, you just don't really know what you're aiming for. You don't really know exactly which phenomena you are and aren't trying to understand. You maybe have a cluster of things that seem related, but it's not really clear whether you're making progress or whether you're going in the wrong direction. And this is just normal. We have dealt with that. It's not something that a startup can iterate on in 2 years, right? It is in fact hard, but we have done it before. Humanity as a whole has done it before.
I guess I feel more angsty about this because I don't feel like there's ever been a time limit before, and now it seems like there is one.
That is very much the issue, yes. In the past, we just sort of stumbled forward and figured these things out whenever it happened to work.
Like the history of chemistry before the model of the atom. You know,
sure. Before Mendeleev would be a better example. Right. The atom actually came pretty late.
The main difference here that we're talking about on the term of something like a decade, give or take a couple years, whereas previous humanity staggering towards something like accuracy took generations.
Yeah.
But with less concerted effort.
Yeah. So the flip side of that is on the previous occasions, it wasn't necessarily as clear what the engineering end goal was. Whereas here, we have pretty clear engineering end goal. Sooner or later, AGI is going to be built. We want it to not kill us. We want it to do what we want instead of something we don't want. That's a much clearer thing to aim for. And we're figuring stuff out as we go and sort of letting that objective drive the exploration.
Right. If people knew what a cart looked like, it would have been much easier to invent the wheel.
Exactly.
I guess you kind of already answered this, but the next heading was, what are we fundamentally confused about?
Yeah. So key things there would be, I do not know, we as a species do not know how to look at a neural network and tell whether it has a general purpose search internally, or what its goals are internally, or what concepts it's using internally. I also don't know how to look at a bunch of atoms, like the atoms constituting a human, and go from here's this bunch of atoms to here's this human's goals, or here are the concepts this human is using internally.
You also mentioned, does this thing contain sub-agents? What are their world models? Would these tools that you're working on work for things in general to that effect, or specifically just for neural networks?
That's definitely the hope, is that they work on things in general. Neural networks are unusually easy because you have the entire low-level specification of the system sitting on your hard drive. It's much harder for an E. coli because we have to go do lots of careful experimenting and measuring just to figure out what all the reaction pathways are before we can start to talk about what computation they're performing, or whether or how goals are represented, or that sort of thing. With a neural network, it's just sitting on my computer, so way easier.
And on the plus side, neural networks are the things that we're most worried about. So it's good that they're
also
the easier
convenient.
one.
Yeah.
Yeah. What kinds of incremental progress do you have in mind?
Think about the things we just listed. For instance, I'm currently working on abstraction. Things like what sorts of concepts, what sorts of abstractions will agency systems naturally end up using? How will they end up representing those internally? That alone doesn't answer all of our questions. That doesn't tell us about goals or subagents or whatever. But that alone would allow us to look at a trained neural network and directly read off what internal concepts it's using. It would be like the holy grail of interpretability, right? That's a form of incremental progress. That's the sort of thing that you would ideally get out of agent foundations.
When you say what sort of things an agent would fundamentally, I forgot the exact phrasing, the things that generalize across agents, like what agents, how they'd model things. And you're looking for this to apply across all things, or I guess across agenthood, all agents.
Or at least something like a pretty broad class of agents.
Okay.
It's one of those things, the sort of results we'd expect are not quite this applies for all agents so much as this applies for the exponential majority of agents. Statistically, we expect it to almost always apply.
Sure. But I guess I'm thinking the things that an E. coli models are different than the things my thermostat models and different than the things you and I model. Is there something that you can kind of outline as the shape of the kind of thing that might generalize across you, me, E. coli, and our thermostats?
So the thing that we would hope generalizes across there, with the E. coli, I mentioned it's tracking how quickly the concentration of sugar is increasing or decreasing as it swims, right? And that's a thing that is natural for an E. coli to think about. It's not something that seems particularly important to a human in their day-to-day life. But once a human goes and looks at it, we can understand what that means. It is the kind of concept that a human can understand. More generally, the idea here is that not every agent will use every abstraction. And in the case of very simple agents like E. coli, they may not even be capable of reasoning over every abstraction. But it does seem like there's sort of a general data type for the kinds of things that make sense as abstract objects. If you have an agent that's powerful enough to understand that general data type, then it should be able to look at the concepts that other agents are using. And even if it's not using those concepts already, it can recognize them as still the kind of thing that it uses as concepts. We talk about the example of maybe some human has never encountered snow. They've lived in a desert their whole life, never seen snow, never heard of snow. And then they go visit a polar region and they see snow for the first time and talk to some people about it. That's a brand new thing. They didn't have a concept for it before, but still very much the sort of thing that they can recognize as a concept once it comes up. It is the right type of thing to be a concept for them.
Awesome. I love that answer. Thank you.
We've dropped the word interpretability a couple times here as a thing that we're trying to get. Can you give us a brief definition of what that is and why we want it?
Yeah, people characterize in different ways. The main way I think about it is the point of interpretability is to take whatever's going on inside of a neural network and interpret it as representing some stuff in the real world. We sort of say sometimes colloquially that a neural network has an internal concept of a tree. The interpretability problem there would be to actually find that internal data structure that represents a tree and then precisely say, like, what is this tree thing in the world that it is tied to? Take that internal concept and interpret it in a robust way as a thing out in the world so that we can interpret the computations being performed with the concept in a way that makes sense in the world.
So we could predict more accurately what the agent is going to be doing with their model of the tree and maybe possibly even change their model of the tree a little bit if we have that power?
Yeah, one thing this would potentially enable is if and when you do get a neural network that's doing some sort of general purpose internal search, if you could detect what concepts it's using in its goal, if it has an explicitly represented internal goal, you could take a look in there and first see what that goal is in terms that you can directly interpret as stuff in the real world. Like, I don't really care if I find that my agent is optimizing for some complicated function of its sensor inputs. That doesn't really tell me anything. I need to be able to interpret whatever the internal data structures are as, for instance, something to do with a human. And second, you could potentially edit that goal, again, in terms of stuff that you can directly interpret in the world. It's not really much use being able to read off or edit goals if the stuff the goals are cast in terms of is just weird representations that you don't know how to tie to a thing in the world that you care about.
And you think this is a possibility in a matter of years?
Yeah, I think that's realistically a plausible outcome. A lot of the reason for my hope here is that it's not necessarily clear which exact things we'll be able to do on the scale of a decade or so, but there's a lot of hope that we'll at least be able to do some very powerful things. This specific story isn't necessarily going to be the one, but I think this specific story is at least plausible, and then there's like variations on it that add a lot more probability mass.
I think this takes us right to your next bullet point, which was, given how slow progress has been on the foundational theory of agency, why do you expect it to go so much faster now?
The biggest thing there is it was not that many people working on it for not that much time, and mostly not working on the core hard parts very directly, at least within the alignment context. Some of these problems people were working on in other fields historically and made quite a bit of progress on in other fields historically, like Perl figuring out causality, for instance. That is a thing that you could reasonably say is a pretty core agent foundations problem, and it's just like a thing that was figured out elsewhere. Or general understanding of optimization. That's a thing that people study in its own right and have gained quite a bit of understanding of, just like in other fields. But within alignment specifically, there's been relatively few people working on these problems for relatively little time.
Is there significantly more people working on them now?
Yes. So first of all, just within the last couple of years, we've gotten significantly more people in the field. And I think to some extent, the top people are probably stronger researchers now than the top people, like, say, 5 or 7 years ago. But I think the biggest factor is not the more people part so much as actually tackling the core problems part. Like Miri worked on things like logical uncertainty, which is an important problem, but not really like the core thing. It's not really a super core thing that if you figure out logical uncertainty, suddenly you've got just way more options for what to do. They did basically figure out logical uncertainty and did not end up with significantly more options about what to do.
Oh, okay. Well, congratulations to them for at least achieving their goal.
Yeah, probably their best technical work to date was logical inductors. That was great.
The core thing being figuring out what agency is and how to understand it.
Yeah, so these things like abstract concepts, things like goals, things like search and optimization, selection pressures, other adjacent things to those.
Okay, so what is the roadmap?
As of right now, the main thing that I'm working on is still abstraction. The sort of next big milestone is being able to directly calculate natural abstractions in simulated systems. The big thing there is getting an empirical feedback loop going on calculating abstract concepts. I've figured out a significant chunk of the math, but the theory practice gap on these things is always pretty wide, and a lot of work is just in iterating on it experimentally. It's not like we have to build an entire AGI in order to iterate on this. So it is the sort of thing where once we get an experimental feedback loop going, you can expect to make pretty quick progress.
And what would an experimental feedback loop look like?
The sort of thing you can picture is you build a simulation, like a fairly low-level simulation of a bunch of stuff, and then you have some function that tries to figure out what the natural high-level objects are in this simulation. Maybe you're simulating a water bottle and a ball and a desk. And so you're hoping that this function will spit out the water bottle and the ball and the desk and decide that these are sort of natural ways to chunk up the environment. And ideally, you do this in a way that's very generalizable. It'd be very easy to write a very special case function that could handle the water bottle and the ball and the desk. But the point of it is to get a function that can handle much more general purpose abstractions than that.
Aren't we already partly there with things like Stable Diffusion being able to insert a ball onto a desk in a picture that you give them?
No. So a key thing here is what the input and output data types look like. With Stable Diffusion, you're passing in the word ball, and then it adds a picture of a ball. And that's not really what we're looking for here. A big part of the reason why there's so much complicated math around this is that what we want is a mathematical representation that precisely captures the concept of a ball. Not just the word ball, but a mathematical representation of the concept.
So something far more complex.
Yeah, it's not, I don't think, so complex is kind of a misleading word there, but it's something that's much more conceptually weird.
It would have to understand what a ball is as a concept.
Exactly.
Okay. There's this line that jumped out at me when I want to pull out and ask about it. It says, real search systems like gradient descent or evolution don't find just any optima. They find optima which are broad and robust, but we don't have good formalizations for those arguments. Can you define what a broad optima is and what a robust optima is?
So a broad optimum means, for instance, in the context of neural networks, you're finding some values of all these internal parameters that's optimal. Broad means if you change the parameters a little bit, your loss is still almost as good. Or there are lots of different directions in which you can change the parameters a little bit, and your loss is still pretty good.
Okay, so meaning when you say a table, we can change around a lot of things about a table, but as a human, we can still roughly say, yeah, that is a table or that isn't a table.
That would not be an example of a broad optimum because it's not clear what's the thing we're optimizing there. Broad optimum is talking about, for instance, a fitness function or a loss function. This fitness function or a loss function is defined over some parameters, like the parameters of a neural net or the genome of an organism. And the broad optimum for that loss function or fitness function means that when you change the parameters or the genome or whatever, it's not very sensitive to that.
Oh, okay. So if there's a few mutations in the genome, you still get a viable creature on the other end.
Yes, that's an excellent example. The more different kinds of mutations the creature is robust to, the broader that optimum is.
Does robust basically mean the same kind of thing? It's similar to broadness there?
So robust is talking about, instead of sensitivity to small changes in the parameters or the genome, it's talking about sensitivity to changes in the environment. If I take the same organism and put in a slightly different environment, or if I take the same neural net and throw a slightly different distribution of data at it, will it still achieve high fitness or low loss?
Okay. So then you said, but we don't have good formalizations of those arguments. What does that mean?
So the arguments here are things like one of the main reasons why we expect ML systems to eventually end up with things like world models or goals or search or any of those higher level agenty things is that those things allow for broader optima and they allow for more robustness to changes in the environment. So that means if we want sort of mathematical arguments, mathematical models for why ML systems will learn these things or why biological organisms will end up with general purpose search and goals and world models and all that stuff, those sorts of arguments or models need to talk about broad and robust optima because that's the core reason that we expect these things to show up in the first place.
Okay, I understand why a creature that is more able to survive changes in its genome is more likely to reproduce and fill an environment, and also why a creature that is robust against environmental change is more likely to survive and reproduce. But can't you just say, obviously, duh? Why do we need the formalization?
So for instance, one interesting agent foundations problem would be you hand me a data set and a loss function and a neural network architecture. And you're like, okay, what sort of internal world models do you expect to develop, or what sort of internal goals do you expect to develop if I train this neural network on this loss function and this data set? And that's something, insofar as we're expecting goals or world models or whatever to come up as a result of broad optima and robustness. If we want to quantitatively say what sort of goals it's going to develop, we need to quantitatively talk about breadth of the optimum or robustness of the optimum. We need to know breadth and robustness relative to what? How do we quantify these? How do we measure these, right?
Huh. Okay. Is there good ways to quantify or measure those things?
So right now, there are methods, but they're all fairly ad hoc. It's not really clear what are the right ways, quote unquote. Ideally, you want quantifications of breadth and robustness that will allow you to naturally talk about what sorts of goals and models and whatnot will form. You don't just want some random ad hoc formalization that can let you sort of say some things, but not particularly robustly.
The next bullet point actually goes right into this. You ask, why do we need formalizations for engineering? So I guess specifically, yeah. And so that's so you can iterate and improve using more accurate terms.
So part of that is so one piece of it is, suppose you're trying to develop thermodynamics. Why is it more helpful to have a thermometer as opposed to an assistant who sticks their finger in the water and tells you how hot or cold it is? That's an important difference. The analogy in machine learning today would be people who try to do variants of interpretability by looking at the internals of a neural network and then spitting out a word that says what thing it's thinking about. If I try to train one network to look at the internals of another network and spit out the word cat, if it's like an image generator generating a cat, that's the analogy of having your assistant stick their finger in the water and tell you how hot or cold it is. What you really want here is something that's more like a thermometer. First of all, the thing it's measuring is sort of a natural thing, and you're getting a quantification of it, and you're quantifying it in a way that's robust to lots of different stuff. You'll be able to use the temperature you measure to robustly make a lot of different predictions about a lot of different things. Those are all properties that you want here. You need formalization in order to do that, to figure out what are exactly the right things to measure such that we can get precise quantification. It's robust. It can robustly predict a lot of different things using that result.
Okay, so like a cat concept that had a broadness of 70 and a robustness of 80 would be better than a cat concept that had a broadness of 70 but a robustness of 54 or something.
More likely, those single-digit numbers just aren't the right data type at all.
Okay.
Probably we don't want to represent broadness as a single real number, and we don't want to represent robustness as a single real number. We want to represent them in some other way, and it's not yet clear what that way is.
I see. So that's part of the work, figuring out how to do that.
Yeah, what's the right data structure here?
Wow. So really fundamentals.
Yeah. And I mean, we're not starting from nothing. We have some idea of what sort of arguments we want to be able to use these for. We want to be able to use our concepts of breadth and robustness in order to talk about when agents will develop world models or goals or whatever, and what world models or goals or whatever they'll develop. And we have some intuitive arguments in there. We can start from what data types do we need in order to formalize those intuitive arguments and turn them into theorems that are actually fairly robust theorems.
This last question down here is, why so much focus on abstraction?
Yeah. Abstraction it's a very convergent subproblem. You can come at the problem of alignment from a lot of different starting points, and a lot of different starting points will all eventually converge on, I need to figure out abstraction. I started out from the angle of value learning. So how do I take a neural net or a human or an E. coli, and I have some low-level representation of them? How do I extract what their utility function is, assuming they have one? How do we do that? I tried some stuff and pretty quickly converged to, I'm first going to need to understand abstraction better. Other people have started from other directions. You can start from an interpretability direction. If you're coming from interpretability, a natural thing you run into is, I'm trying to interpret the internals of this neural network as representing some stuff in the world. Ideally, I'm trying to interpret them as representing some human intuitive concept. But if you want to go very far with that, you pretty quickly run into the problem of what sorts of things in the world are human intuitive concepts. How do neural nets end up representing those same things internally? Do neural nets even end up using those same things internally? You immediately run into problems of abstraction. There are other paths too. It's a subproblem that you run into pretty consistently.
And again, abstraction being the thing, the difference between a table and a piece of paper on it, as opposed to just like all the atoms in a general area.
Exactly.
I guess the last thing I have before we move into the follow-up to the plan post is you say you think agency and alignment work will undergo a phase transition in the next approximately 5 years. What do you think that phase transition is going to look like? Is it going to be based on solving the abstraction?
Based on abstraction is one possible path. I am more confident that there will be a phase transition than I am in any particular path. What it will look like is the field will start to look less pre-paradigmatic. It will start to have something which more closely resembles a paradigm. And a paradigm based around abstraction is one possibility there, but there are other possibilities. Another one could be something based around selection pressures and selection theorems, which we didn't really talk about, but like that's another possible route that I think about. And there are probably other routes that other people are thinking about that haven't even occurred to me yet.
Well, the next one, the next post, basically the first thing you say is, I tentatively think the general shape of the paradigm has become visible. Can you talk about that?
Yeah. So as of writing the plan, I was like, well, I'm highly uncertain what the paradigm is going to look like. Now I think it's much more likely that it will be something centered around abstraction. And the main reason for that is just that we have seen like multiple of the top researchers converge to working primarily on abstraction over the past about 18 months or so. Paul Cristiano is another example there. The whole like ELK agenda is very much centered around understanding abstraction in the same sense that I'm trying to understand abstraction, basically. Also, Scott Garibrandt has been working on this, although he hasn't been writing publicly on it as much. And of course, the interpretability people, also many of them are sort of moving in that direction.
You think over the next 1 to 2 years, they're going to converge on this decoding of the internal language?
Yeah, so to be clear, this is not like a very confident prediction. I wouldn't even say it's better than 50-50. I would say like 40%, maybe. But it's still, this is a very specific prediction to be putting 40% on, so.
Do you think it'll be solved within those 2 years, or just like a thing people are going to be crunching hard on?
I would say, hard to say. If I just extrapolate my own work, like if I continue to make progress at the rate that I'm currently making progress, then I would guess within 2 years, it's basically, abstraction is basically nailed down, at least like the mathematical end of it, and we're like cranking on the empirics.
Nice.
But that's assuming that my own personal progress continues at the current pace, which is always a big assumption to make.
You said you wouldn't give it a 50% chance, which reminded me that you had said that you gave in the previous post a 50-50 chance that the plan will work before AGI kills us all.
Yeah.
Inyas expressed optimism, or an optimistic result, and you had said that's just your take. You wouldn't necessarily expect everyone to agree with that number based on what their priors are, which I get how that makes sense for what people's priors are. But given that you know a lot more about this stuff than I do, that's a pretty strong update or pretty strong evidence for me, right?
I mean, I do not generally recommend reasoning that way. That's my answer there. I think you should, like, if you're at a level where you're following this discussion in the first place, then I think you should mostly be trying to build your own models and not just updating based on, well, person X seems to know more than I do, and they seem to think Y, so I should update towards thinking Y.
Okay, I see what you're saying. I still think, like, if Neil deGrasse Tyson came out tomorrow and was like, we actually think the universe is closer to 15 billion years old, I'd be like, if you say so, now I think that too.
Sure. Yeah,
but I'm also
that
not.
Sort of reasoning works well with something like the age of the universe, in part because there is, like, astronomy in general is like a pretty paradigmatic field. There's like some room to disagree on what the age of the universe is, but we have a lot of pretty clear evidence. There's pretty strong agreement on it between people. With alignment, it's not like that. There is, even among the people who know this pretty well, there's a lot of disagreement.
That makes a lot of sense. And I'm reminded of the fact that, because you draw a lot of analogies to, like startups, and I've worked at a couple of startups, and that's how these things go when you're working on new projects. Even the people who've been doing this for 10 years longer than I have and are really good at it, there's still room for disagreement because no one knows exactly what it is that we know
exactly
what we're trying to do, but if someone's like, oh, we should do it this way, even I'm equipped to say, well, hold up a minute.
It's not like any of us have done it before.
Exactly. Yeah. All right. I love it. Perfect.
The other thing that I pulled out was that you said, I've updated from just aim for ambitious value learning to empirically figure out what potential medium-term alignment targets, example given human values, corrigibility, do what I mean, human mimicry, etc., are naturally expressible in an AGI's internal concept language.
Right.
And I need a little bit of help parsing this, starting with what's naturally expressible. When you say figuring out which medium-term alignment targets are naturally expressible in an AGI's internal concept language, what does naturally expressible mean here?
For humans, we have some natural concepts, right? There are things that are natural for us to think about. There are probably things that are not very natural for us to think about, but usually we don't have words for those because we don't naturally think about them. But you could imagine if we were the AIs and like someone else were coming along and trying to figure out how to get us to do what they wanted, at the very least, they would have to like translate what they wanted into internal concepts that we know how to use, right? Like imagine I'm a manager at a company. My employees have some concepts that they're used to using. If I want to get those employees to do what I want at all, step one is going to have to be, I'm going to have to take what I want and translate that into concepts my employees understand. Translate it into the concepts that are sort of internally natural for those employees. And it's the same thing with AI. If we want an AI to do what we want in a way that is robust and we can tell that they're doing what we want and all that, then step one for any decent plan along those lines is going to have to be figure out what are even the things that are natural to express in terms of the AI's internal concepts.
Aha. And that's why the focus on the abstraction.
And again, I mentioned there's more than one path. Abstraction is a very convergent problem. There's more than one path to it, and that is one of the paths.
You say that you mostly aim for robust bottlenecks in doing this thing, in trying to find what things are naturally expressible. What do you mean by robust bottlenecks?
So I mentioned that there's a lot of paths to abstraction as a problem. Like there's a lot of different places you can start from, and you end up eventually needing to figure out abstraction. What that means is that abstraction is a robust bottleneck. There's a lot of different strategies you can be thinking about, or a lot of different approaches you can be thinking about that all converge on this same subproblem. So abstraction is a robust bottleneck in the sense that like it is a bottleneck for all these different approaches, all these different strategies, and it's like robust across all of them. Part of the reason to focus on those sorts of things is we don't necessarily know now what the right approaches will be or what the right strategies will be. But if something is a robust bottleneck, if it's robust to a whole bunch of different strategies and approaches, then it's very likely to be a bottleneck for whatever ends up being the right approach.
Are you familiar with other robust bottlenecks, or is this the only big one that's on your radar right now?
I think abstraction is the thing that's sort of the lowest level thing that we can cleanly identify as a robust bottleneck. There are other things like being able to iterate is a robust bottleneck. So like being able to make a change to a neural network and see whether it is now safer or less safe, for instance, or see like really anything about its internal cognition, how it changes when you change the net. That's a fairly robust bottleneck. Pretty much any realistic plan to solve alignment is going to have to find a way to do that. That's another example. We could probably come up with more if we spend 10 minutes on it.
Yeah. Okay. That covers most of what I had from those two posts. Me and Stephen have a few more specific questions here to hit at the end, if you're okay with that.
Yep, go ahead.
The first one I had is, how's this progress on the thermometer of abstraction coming?
Moving along. So it's still mainly bottlenecked on getting the math to a point where computations are actually tractable. Like at this point, there's enough math. We've sort of nailed things down mathematically from enough different directions that it's pretty clear we're like looking at the right meaningful things. The results so far have basically been like take 3 different ways of trying to formulate what sorts of things would be natural abstractions. And then we find that all 3 of them end up roughly equivalent. And when that happens, you're like, oh man, I'm clearly on the right track here. But they're still extremely hard to compute. A lot of what I've been working on over like the past few weeks, past month or so, is hammering that out and getting to the point where we can efficiently compute it and, actually start doing experiments.
Do you think sometime this year?
Yeah, I would be surprised if by the end of March we're not at that point.
Oh, shit. Okay. Tell me if this is even worth asking or if it's just too much to get into. You mentioned a few times in both the posts modularity of evolved systems, and I was wondering what that was and if it's relevant here.
Yeah, so in biology, for instance, we see a lot of modularity in the internals of systems, meaning that, for instance, you can make a single gene change in a fly and its antenna will turn into legs, just like legs on its head.
Yeah.
And that's not a thing that happens in non-modular systems. When you make a single gene change in a non-modular system, the whole thing just breaks. Everything gets weird. In order for an antenna to turn into a leg with a one gene change, there has to be like a pretty clear leg module in there. It's modularity sort of in that sense. Like there's some stuff with pretty specialized functions that's not just connected to everything else all over the place, right? It's interesting that this is a thing which evolves. Things have evolved to be modular in this way. Normal selection pressures were somehow enough to do that. And this is interesting, particularly because a lot of the sort of core things that are interesting about selection pressures in natural evolution mostly carry over to the case of gradient descent.
Quick definition of gradient descent?
Gradient descent, as in you've got some continuous loss function and you're going downhill on that loss function, as we do with neural networks.
Okay. Stephen, did you want to hit the next one?
Given, with the asterisk that you're one guy working in a greenfield area of research, I'm trying to think of a way to ask without trying to say how'd you come up with your exact probabilities, but I don't know. The main person I've read a lot of their stuff on AI is Eliezer Yudkowsky, and he's much more doom-minded than you seem to be, which I like your approach more because I don't like the doom mindset. Now, I don't want that to be the reason that I am not doom-minded, right? It's not an attractive place to be, but is it like a couple of big cruxes, or is it just different major perspective?
So the first piece of advice I would give here is my optimism is largely coming from things I have seen that are not particularly externally legible. Like I can see how fast my work is moving, sort of have an intuitive sense of that. I do not necessarily think you should be putting very much weight on that. That is a thing that is visible to me. It is not visible to you. And it's something where like you shouldn't necessarily just take my word for that. I know how trustworthy I am. You don't know how trustworthy I am.
Fair enough.
Like lots of people will just say their work is going really well. That's a common enough thing that it is not obvious from your perspective that I'm not doing that, right? I think from your perspective, you should actually be putting more weight on the sort of stuff Eliezer is saying than the sort of stuff I'm saying. And I do think if I set aside things like how fast I see my work going, and I just pay attention to what sort of visible progress has been made in the last few years, or how the visible parts of progress have been moving in the last few years, then I'd say I'm like, basically I'm bored with Eliezer if I'm just thinking about that.
I follow you. I mean, granted, you work on grant money. You don't want to tell the people paying you, I've been wasting your money all these years. I haven't made any progress, actually. So maybe you could be just full of it. But I understand where you're coming from, that stuff that's not available to me, it'd be like telling somebody, I'm pretty sure, just take my word for it. And like, that's not a good enough reason, right?
Like if someone comes along and says, yes, there's this hard problem, and I think I'm going to solve it in the next few years, you should be like very skeptical of that, right?
That's when you phrase it that way.
Ways, that is what I'm saying here, and you should be appropriately skeptical of that.
No, that's fair. When you phrase it that way, for sure. Okay, I understand. That makes sense.
We are nearing the end, so I wanted to ask, actually, these next two questions might be the same question, so I'm going to ask them both at the same time. Where can people learn more about you, what you're doing, your stuff, and what's the basic foundations sequence? And should I break up those two questions?
So I write a ton on Less Wrong. If you want to see the whole shebang, there's an awful lot on there.
I can verify, tons.
There's a lot. Specific things people might be interested in. If you want to read more about natural abstraction stuff, you can look at the abstraction tag on Less Wrong. There's a few things on there. There's also various posts that I have on the topic, like the telephone theorem, natural abstractions via resampling, the minimal latent approach to natural abstractions, a couple of project updates. That all has good information in it. Then there's other topics. For instance, you bring up the basic foundation sequence. The basic foundation sequence is taking the conceptual ideas from how I'm approaching abstraction and thinking about how to reformulate basic concepts of agency in terms that play well with abstraction. Things like goals, for instance, or things like how do we separate an agent from the rest of the world? And then there's just a whole lot of other stuff. General world models, posts on general topics, posts on how to do research, all that stuff. There's a lot.
All right. I will include a smattering, perhaps a plethora of links in the show notes.
Nice.
What can listeners do? And I'm going to start with like a somewhat expert level listener, someone who knows a lot about programming and possibly even AI research, what can such a listener do if they are inspired to want to try to help with what you're doing?
Yeah. Okay. So first of all, the way I personally categorize things, someone who knows a lot about programming and maybe AI, I would not consider an expert. We have quite a few people who know a fair bit about programming and like a moderate amount about AI. The people I would consider experts for purposes of Agent Foundation's work are people who have a pretty decent knowledge, not just in programming and AI, but also in economics, biology, maybe some statistical physics, like a lot of different fields where these sorts of things are relevant, maybe neuroscience, maybe psych. The relevant sort of expertise is much less about deep expertise in programming and much more about broad expertise in a lot of different areas that are agency relevant, and also just general math skills, of course.
Mm-hmm. What could a person who has this sort of math skills plus broad knowledge do to help?
The entry point I'd recommend for someone like that is the embedded agent sequence. They don't outline things in quite the way I would, but I think they do a decent job of introducing a lot of the sort of core problems. For someone with that sort of background, the sorts of questions you want to be thinking about are things like, okay, I think about markets or cells or neural nets or whatever as things that have goals and world models and so on and so forth. How do I talk about that mathematically? What sort of theorems can I prove about it?
And do you think that if they have a lot of knowledge like that and math skills and they've read those sequences, then they would be able to start working independently on this sort of thing?
Yeah, I would guess someone like that will at least have a few sort of intuitive threads to pull on. This is assuming they have the general skill of taking an intuitive concept and starting to probe it mathematically, turn it into theorems, that sort of thing.
Once they're there, should they contact you or some other organization or try to get grant funding, or should they just think and take notes? If you want to get
grant funding for that sort of thing, then the Long-Term Future Fund is probably the easiest place to go at this point. Although I would note that after the FTX collapse, some of the grant makers are just like overwhelmed dealing with aftermath of that. My guess is that'll clear up. If it hasn't cleared up already, then within the next month or two. So like right now may not be, you may get turned down and yet you may like get accepted in like 2 months or something.
What about someone like Stephen or myself that doesn't have, a lot of knowledge or math skills and basically just talks to people but wants to help in some way? Is there anything we could do?
I was going to say, what can the rest of us who check none of those previous boxes do? But I think one thing, if you mentioned specifically, Eneasz, you and me, we can expose the kind of work and arguments that people like John are making to hopefully new people that haven't heard it before. So that's one thing.
Yep.
Anything else that...
Yeah, so for someone who can't just immediately dive into independent research on Agent Foundation's theory on their own, the MATS program is like, I've been designing a sort of onboarding program that's intended to get a lot of the way there for people with multiple different skill set backgrounds. So like on the way in, I'm like categorizing people as specializing in theory or in experimental work or in communication work, training skill sets for all of those. Obviously, I can't train everything. I can't give people 10 years of technical knowledge overnight, but I can train a lot of the like skills that you need day to day for this sort of research. So that's one route. This is the SERI MATS program. I have a post or two. I think one's called MATS Models that talks about it. And there's also a more recent one, not a post by me, but a post that's, it has John Wentworth's MATS stream in the title. So that's like talking about what sorts of training we do there.
And someone who's in their 40s, 50s, working a day job, nothing to do with this sort of stuff, can do basically just provide moral support, anything on that end? Or do we just cheer and hope?
There are plenty of people in their 40s and 50s working a day job who, in fact, have lots of relevant technical knowledge and could probably do just as fine as researchers. But especially for people in academia. And also, to some extent, people who are in the startup scene, it's not uncommon to have a lot of the relevant skills. But if you are just like a person who is not going to be doing the core research, then yeah, at this point, I would mostly say we don't really have a good way right now to make good use of you. But that may change at some point in the not too distant future. We'll see.
If it does change, we'll try to get the word out. And also, I think I personally am going to update, and I hope everybody else also updates in the direction of, if you think you were too unskilled for this, check out the Matt's Models link and see if maybe actually you can do something, because it sounds like you're saying people can help more than they think they can.
Yeah. If you're actually looking to start doing research, I think there are fairly specific exercises that you can do that will install a large chunk of the necessary skills. Very often, the skills that we can install that way are the things that a particular person was missing.
Okay, great. So you probably can do it. Don't get discouraged.
I like it.
Don't quote me as being that optimistic, but there's non-zero hope there.
Okay, cool.
I think in general, people just tell themselves it's too hard and then never try. So at least don't stop there.
The case. There are lots of people who will tell themselves it's too hard and will not try, who would in fact have been able to pull it off.
All right, well, that brings me to the end of my stuff. Stephen, did you have anything you wanted to add?
No, we hit everything. This was great.
John, did you have anything you wanted to add that maybe I should have asked and I didn't, or that you just want to throw in at the end here?
Nothing springs to mind.
Excellent. I am awesome at this.
Good job.
Thanks. All right. Well, we're getting close to an hour and a half. So thank you for staying extra with us to cover all this. And keep in touch. Let us know how things are progressing in the future.
Mm-hmm.
Awesome.
Great.
All right.
Bye-bye. Thank you.
Thanks
Bye.
again.
We are going to do the thing that we always do now, where we tell you a cool thing that the Guild of the Rose is doing.
And if anyone does hear this and decides to check them out, email us at Bayesian Conspiracy podcast@gmail.com, or maybe comment on an episode or something, just because I'd be curious if you guys checked it out as a referral and how you're doing, how it's going for you. But I suspect everyone who listens to this will love it there. They just introduced a course on feeling rational, which, if you guys remember your sequences, this counters I think what Julia Galef called the straw Vulcan.
Yeah, they called those sequence review courses, where they go back some critical material from the sequences and practice internalizing its lessons. They've also, I guess this is a little bit late now because we're near the end of the month, but they also released this month Setting New Year's Goals, an opportunity to collaboratively apply the best practices in goal setting to your top ambitions for 2023.
I suspect the New Year's goal thing, it's not New Year's anymore, but everyone's got ambitions, and if you're the kind of person like me who's like, I wish I was doing this, but I'm not, well, have they got the course for you?
Absolutely. You can always set goals whenever you are. In fact, I strongly recommend it. I've always thought it was kind of silly to wait until the new year to set your new goals. I guess it's good to have a Schelling point where you consciously think about setting new goals, kind of like, birthdays and Christmases are a time you consciously think about giving presents, because otherwise you just wouldn't ever get around to it. But yeah, you can set goals whenever. Do it now.
Yeah, so set goals whenever and do them at the best time. And if you want, tips and tricks on how to actually get shit done, check out the Guild of the Rose, their workshops.
Hell yes. Okay, quick feedback thing. We did have someone ask after our last episode, hey, haven't heard Jace in a while. What's going on with Jace, guys? And we have an update on Jace. Jace has been taking a bit of a break from the podcast due to a particularly stressful and high hours new job that he has, plus various things in life. And we talked about it recently, and it sounds like the break is going to be continued on for a while. So maybe Jace will be back in the future, maybe not, but we're going to be continuing on without Jace for foreseeable future.
For the foreseeable future is a good way to put it. One way or another, unless, he steadfastly refused. I insist on having him back for occasional episodes if he doesn't want to be a full-time partner again. But we're sorting all that out, so.
Yeah. And now, the less wrong posts.
Yeah, the first one is Expecting Beauty.
Gosh, how long has it been since we did less wrong posts? Did we do them last episode?
It's been well past when we typically do them. I think we've missed at least 2 episodes, then we took off winter holiday. It's been a month or 2.
It's been long enough that I think I should very quickly give the context for this. The previous episodes were discussing the mathematical systems and the underlying beauty that emerges out of them, and how you can take some time and just dive into it and kind of be blown away by the elegance and the beauty of mathematics. So these posts continue on from that.
What I like about these is that it's like, this was what I loved about Richard Dawkins' Unweaving the Rainbow. Here's a guy who's just crazy about the poetry and not magic explicitly, right? Explicitly not magic, but the joy, the thrill of nature and science and understanding, right? This is that, but for numbers.
Yes.
And it's just great. Whatever anyone's excited about something and they're talking about it, it always makes me happy. I don't necessarily have the same math boner that he has, but I can appreciate that he's stoked on it, right?
Totally. The first post is about expecting beauty. He gives a sequence of numbers and says, suppose that you're handed the sequence. Clearly, it doesn't have the same neat order that we saw in the squares, so you might try to impose some order. And he goes around giving some hypotheses about how someone might try to impose order on these things, and how it's kind of clunky and doesn't work very well because the numbers don't seem to have a pattern that is easily recognizable. And therefore, the people, the onlookers, the naysayers out there saying nay, will say things like, this is what happens when you always try to find beauty and elegance everywhere. Real life is much more complicated and messy than all that, you math nerds. But Eliezer goes on to, find a way eventually to get beauty out of it. And obviously he's working with a sequence that he knew was going to lead to beauty. So it's a slightly contrived example, but it's an example of a point. And he says, look, you keep working at it, you keep diving down, you can find beauty and elegance after all. The problem was that the first person trying to impose beauty and elegance and order on this thing grasped too quickly at order and demanded closure right now and forced a pattern. And someone who does that might never find the stable level of the actual emergent, elegant pattern to it. If you try to tweak the first differences you find to make them more even and fit your own conception of aesthetics before you found the math's own rhythm, he says, then the second and third differences will come out wrong. The moral is to reduce at the right time and wait for an opening before you slice, not to prematurely terminate the search for beauty. So as long as you can refuse to see beauty that isn't there, you've already taken the needful precaution if it all turns out ugly.
I like it. I think the only quibble I could imagine with that summary would be it's at the emergent beauty. And I think that emergent is one of those
Oh yeah.
So I'd also say that it's not it's not even in the context where people like using the word emergent beauty. It's underlying beauty, right? So the beauty of, I'm glad he chose something simple like squares to start, because some of his math examples, the inferential distance is a little high for me and doesn't make good audio.
Oh God, wait till we get to the quantum mechanics sequences.
I wonder what we'll do with those. We'll figure it out. But they're
going to have to be much more reacts rather than talking about exactly what's happening in them.
Right. But it is kind of cool because, you can picture squares. And once you kind of get the picture where it's oh yeah, 5 on one side, 5 on another, 25, 6, 6, 36. Once you get the pattern, you can visualize it. Mm-hmm. And so it is kind of just this underlying principle of it, right? Mm-hmm. I'm sure there's emergent beauty in math too that I just am not equipped to pontificate or understand about. So
one of the things I really like about this post is, it's not just saying the naysayers are a bunch of jerks and don't accept their needling too easily, but it also is don't jump too quickly at this stuff. Don't be the overeager person. The most zealous person is always the new convert, right? And you don't want to be that extremely zealous new convert kind of person. It's important to refuse to see beauty that isn't there. Just because you want there to be beauty, don't try to impose it. I think it's a lot like, sexual relations in that way. If you try to force it, it's never going to work. You got to wait until it emerges, and maybe it won't at all, but maybe then it will. And math is kind of the same way. Doing math is like chatting up and kissing a beautiful woman. You don't force things.
Well, and you're not going to find whatever the best parts without some practice.
That too.
If your first time with a partner is the best ever, then I guess you guys won the lottery. But usually it's all right, now we know each other's rhythm, I was thinking
so the first derivative didn't work.
I guess I'm hung up on unweaving the rainbow, but the idea that God made rainbows and aren't they pretty? That's one way to appreciate a rainbow. If you understand how rainbows actually work, you might say, well, look, you ruined my version of how pretty it was. And it's no, man, I gave you a really cool version of it. And isn't that beautiful in its own unique way, or in its own new way? Right now, I look at the window, I can see a sunset. God made sunsets. Isn't that nice? And it's well, that's one answer. But understanding the reality of it has its own beauty to it. I guess what I'm trying to say is shoving on your first example of stuff, I think it's a failure pattern that applies to other kinds of things.
Absolutely. And that actually segues very nicely into the next post.
Almost like I did it on purpose.
The next post is reality ugly? He asks, is the real world uglier than mechanics?
Mathematics.
Sorry, what did I say?
Mechanics.
Well, mathematics, yes. And he says, yes, strange that people ask this. Beneath the complex forms and shapes of the surface world, there is a simple level, an exact and stable level whose laws we name physics. And he calls this the Great Surprise, which I think is a great way to put it, because you wouldn't have just guessed that naively if you didn't know any of this and looked at the world. He said, once upon a time, people went in search of underlying beauty with no guarantee of finding it. And once upon a time, they found it. And now it's a known thing and taken for granted. But that's kind of fucking crazy, right?
It is. I mean, I always like learning about, how did the ones that helped figure out with actually pretty solid accuracy the rough circumference of the Earth. And how did they do that without being able to travel farther than you can walk? And it's like, well, they could do a solstice at one city, put a stick up and get a perfect non-shadow. They could do a solstice several miles to the south the next year, stand a stick up, and then measure how long the shadow is and do some trigonometry, right? And so it's crazy seeing how they get there. Again, that's doable with 3,300-year-old math, right? The only quibble I would draw with Eliezer's thing here is, the simple, exact, and stable level we call physics. And it's like, all right, well, you say that, but then I stopped reading popular science books once they always started talking about the wave function.
Right.
If you can explain to me how that's stable and simple, then I'll quit challenging you on this. But I think physics is like the answer to how stuff works. Yeah. And you can get to a good enough explanation without getting to the bottom level. So he says, beneath the complex forms and shapes of the surface world, why does blowing on a spoonful of hot soup cool it down? The answer is simple and cool to explain and cool to understand.
Would you like to explain it to us?
I don't want to ramble on too long, but the short version is it's like heat is the measure of how fast the molecules are going in whatever it is you're measuring in, or heat energy rather, and temperature is the average that, so when you've got a liquid with fast molecules in it, some of them escape the surface. It tends to be the fast ones because they've got the most escape velocity. That's why you're seeing steam. Blowing on it creates less pressure behind. It's a lower pressure zone for the molecules to escape into.
So it makes it easier for them to escape.
Right. And since on average the faster ones escape, the temperature drops.
Cool.
But if you're going to ask me, all right, well, explain that, but talk about quarks instead of atoms, I'd be like, no.
Right. Yeah. I think what he means by simple and stable level is that it can be summarized in a number of equations, which is kind of mind-boggling.
Yes.
When you look at just how complex the entire universe that grows up out of them is.
Agreed. I'm totally on board. I think it's because he mentioned quantum physics earlier that I was like, well, hold up a minute.
It's not that easy.
Right.
You need at least 1 degree to understand this shit.
Yes, and I only have a theoretical degree in physics, so...
Right. So he does ask that sort of thing, like, why is it that if there is these simple, exact, and stable level, where you can sum up everything that the universe does in a few equations, why is it that you can't predict exactly where the tiger is and what bush he's going to jump out of, and so forth? He covers 3 big sources of uncertainty in answering this question. The first is that you can be governed by stable fundamental rules without knowing them. We do not yet have a theory of everything. So first, we just don't know all the rules as they are even at this moment. He also says that even when you know all the relevant laws of physics, you may not have enough computing power to extrapolate them, which I think is pretty much what you were saying with the blowing on the spoon. How do I translate to quarks? Just no.
And I think this is probably from another post, but like there's also like a useful level to abstract something to.
Yes.
Like if you're modeling, I think he probably used the example because it sounds like something he would have come up with. The example of the Wright brothers testing wind tunnels, even if they were thinking in terms of atoms, let's assume that was on their list of options. It would have been ridiculous to think of the plane of a wing in terms of quarks, right? Let's think about it in terms of like a solid, like an actually solid, flat-ish, disk-ish thing, and figure out how air moves over it best.
Right. Like we're not even thinking in terms of molecules at this point. It's just a solid object that we're working with, and that works.
Right.
You'd never get anywhere if you were trying to do quark simulations.
I think I mentioned this years ago on the show, but do you remember that episode of Rick and Morty where they're all in a simulation for some reason?
Uh-huh.
And Rick is in the garage ripping apart a rat, and he's like, this is just bad craftsmanship or something. I'm assuming it's because the rat didn't look like a real rat on the inside. Okay. Like it was some cheap version of, like when you're playing a video game and you can move the camera, you get the character close to a wall and the camera moves inside their head. And you see like this horrifying back of eyes and teeth, and that's it.
Right.
Because it would be such a waste of computing power to simulate a circulatory system inside the, every NPC, right?
Exactly.
So, anyway, a level of abstraction that's appropriate.
At this point, I want to quickly mention I was just introduced to a show. You saw Parks and Rec. Who was the guy that plays Ron Swanson?
Nick Offerman.
Nick Offerman, that's right, with the amazing voice and these piercing eyes, right?
Yeah.
He plays one of the main characters in this show on Apple Plus called Devs, and I've only seen the first 2 episodes, so I don't know if I can actually recommend this. From the first 2 episodes, it's really fucking compelling, though. It's done by the same guy who did Ex Machina and Annihilation. It's like good, high-concept sci-fi, kind of mind-bendy. Based on how those other 2 movies go, I assume that I'm going to be slightly disappointed by the ending, but the trip is going to be absolutely worth it. From what I gather in the first 2 episodes, it is about a tech company in the near future that creates a computer powerful enough to literally predict things down to the quark level, and so they can literally predict everything forever.
Neat.
As far as I can tell, yeah, and what the implications of that are. So far, I'm really loving it, but let's see if I continue to love it. I don't know. I wanted to tie in, we do not have enough computing power to extrapolate them, but what if we do? Here's an awesome sci-fi concept.
And it looks like it's on Amazon Prime and on Hulu if you already have a subscription. Well, Google it. Find out where you can watch it.
Okay.
All right. Anyway, sounds like fun.
All right, and the third area of uncertainty that he spoke of is, he says, to figure out what the night sky should look like, it's not enough to know the laws of physics. It's not even enough to have the logical omniscience over their consequences. You have to know where in the universe you are. And that might be a thing that you don't know, metaphorically speaking, with whatever it is you're trying to figure out. So 3 big sources of uncertainty which make predicting absolutely everything very difficult, possibly impossible.
When he's saying uncertainty, he means the inability to perfectly predict the future?
I think so, yes.
Okay.
Yeah, like you can perfectly predict what the next number in that sequence is going to be, but you can't perfectly predict whether you're going to run into a tiger tomorrow.
Right.
He goes on to say that ignorance of fundamental laws does not tell you that a messy-looking pattern really is messy. It might just be that you haven't figured out the order yet, that's right. That's why we were covering those 3 sources of uncertainty. That reality might look messy to you, but not actually be messy at the most fundamental level. But he does give the caveat that when it comes to messy gene expression networks, we've already found the hidden beauty, the stable level of underlying physics. But because we've already found the master order, we can guess that we won't find any additional secret patterns that will make biology as easy as a sequence of cubes. Knowing the rules of the game, we know that the game is hard. The elegance, the rules that govern physics, is too far down to help us overcome our indexical and logical uncertainty. Similarly to how, knowing the basic few equations of the laws of physics is not going to help you describe blowing on that particular spoon.
I mean, it depends on how deep of a problem you're trying to solve. Like, the fact that they mentioned squares in biology is fun because, like Punnett squares, you've got, say, a trait, blue eyes. And if you know it's recessive and you do the parents and then the possible permutations of that, if they each, say, have the recessive gene, and you can figure out the probability that the offspring will have it. It turns out that if it's blue eyes and if both your parents have brown eyes, but the recessive are blue, I think your odds are 25%. It's not exactly 25 because it's not quite that neat, but it's close enough for a lot of stuff. Like the Mendelian pattern of inheritance.
That's the word I was thinking of.
Yeah. So, there is some cool, simple stuff. But if you want to know, like, how tall is my baby going to be? Like, that's going to be harder to figure out, even if you have their full genome and can understand it, actually.
Right. Because a lot of things impact that after birth as well. Or even, after conception, I guess.
Yeah. And after birth.
And after both. Yeah.
Somehow I have an identical twin and I think like an inch taller than he is.
That's nuts.
I mean, and it's a reasonable fraction of our total height because it's not like we're 6'7".
I mean, an inch is a lot for anyone, no matter how tall you are.
Phrasing.
But
I bring that up because even with identical genomes, my brother and I have different heights.
Oh, did you fill out the not Slate Star Codex, Astral Codex 10 survey this year?
No. I need to get like on some email list for these things.
I was going through the results, and there was I believe 76 identical twins. And I was like, hey, I know 1/76th of all the identical twins that read ACX.
Alas.
But apparently I do not.
Next year. Anyway, height is more complicated than eye color.
Yeah. Finally, he says, again, but bring us back to whether things are beautiful or messy, but uncertainty exists in the map, not the territory. If we are ignorant of a phenomenon, that is a fact about our state of mind, not a fact about the phenomenon itself.
That's the bumper sticker.
Exactly. Yeah, that's a good one. I was just wondering, so in the end, like, is reality ugly, in quotes, for this definition of ugly?
Define ugly. Give 3 examples.
Give
1 example.
Okay. I was meaning the beauty of, like, the mathematical type of beauty.
I mean...
Of order and patterns.
But I think that, to the proper level of abstraction, it works for the caveman who can't count. They might not know math, but it's like they can anticipate where the stars will be, because they've got nothing else to do. They spend all night looking up, right? I think that there's a beauty in that. I'm bad at these sorts of questions.
I guess it's a 2-part question. Like the first part being, do you find beauty in relatively simple, stable patterns that are easy to state explicitly? And do you believe that reality looks like that? I guess if the answer to both of those is yes, then reality is not ugly.
I think reality looks enough like that. It does seem to say that, like, the more your understanding goes up, the prettier or uglier it can get. But again, I think I'm perfectly happy with my understanding of, like, why a plane wing creates upward draft without having to reduce it all the way down to quantum wave function. So, like, I think that at the right levels, things are totally fine. And somebody looks at the wave function and, wants to get it tattooed on them because they think it's beautiful. For me, it just makes my nose start bleeding when I look at it. So it depends.
I think you can have 2 different kinds of beauty, because I think, like, the beauty of light refracting inside of a crystal and how orderly and easy to define that sort of thing is, that the patterns from that is beautiful in one way, but it's beautiful in a very different way from, like, a touch and a kiss is. And I think if you can appreciate both types of beauty without thinking that they're in conflict, then reality can certainly be beautiful. I think it's only if you think that one detracts from the other in either direction, then this might be an issue with reality being ugly or not.
Yeah. I don't want to say it's a wrong question, because I know you're stating it rhetorically, but if someone, like, tried to push me for a real answer, that's what I would say.
Okay.
What could you possibly mean by that? Hitler existed. That's terrible. That was ugly, right? Like,
right.
Does that mean that reality is overall ugly? What the hell does that mean?
Yeah.
Right now, puppies exist.
Yeah.
There's a small child getting their first puppy kiss right now somewhere on Earth, and that's the most beautiful thing in the history of the planet, right? But does that mean, like, reality is not ugly? I don't know. That's a weird question.
Is the fact that could, in theory, be captured in a wave function and described mathematically if you knew things precisely enough, is that beautiful or ugly?
I think it'd be a very long equation.
Sure. Yeah.
That's all I can say.
Okay.
If I was really, really good at math, I'd probably think it's awesome.
All right.
So, all right. On the last philosophical note, do you ever imagine that it could be possible with? I mean, I'm going to have to constrain it some way. It's some sort of a brain that your brain could theoretically evolve into while still being vaguely called human, to where you could look at a giant equation and be like, that's a puppy kissing somebody, and it's beautiful.
Not and be human, no.
No, I don't think so either. I remember hearing somewhere that allegedly some music school, like I
heard about this.
Yeah, they would just, like, read the composed music pieces by the graduates, and, like, they would just look at it.
Yeah, and they could hear it because they know what notes correspond to what sounds and all that. I can totally see that.
Well, that's the thing, though. Depending on how complicated your thing is, could you actually... maybe they must be able to, or they at least say they can. Maybe they look at how pretty it looks, and they just determine from that, right?
I absolutely believe that you could read sheet music and hear the music in your head if you have the skill to do it. Like, we can read words and see beautiful images in our head, right?
What if it was an orchestra, like, that you're composing for? Like, it's half a dozen different musical groups.
Yeah, I don't know. Maybe if you have the ability to read all 6 tracks or whatever they're called and keep them all in your head at the same time, it might be possible. You probably have to be a genius.
Any music savants out there want to let us know? I'd be really, really curious at the answer. Anyway, what are we talking about next time?
Next time, we are reading the Less Wrong Post's Beautiful Probability and Trust in Math.
All right. And we also have to thank our patron.
Yes, we do. This week, we would like to thank our patron, Matthew Baggins. Thank you for supporting the show. It means a lot to us, honestly. Also, for people who are patrons, we have at least two things. In our previous episode, we digressed a lot, and I never know how many digressions to leave in and at what point is it charming and what point does it get too much. So I pulled out a lot of them into an 11-minute track of digressions that I put up only for patrons, and at least one person commented on it that it was total genius, and they loved the fact that there weren't any dividers between the various digressions. So that is available for people who want that. And also, Stephen, you put together an entire free episode for patrons only.
Oh, yeah. Wes and I talked about prenups. Wes, friend of the pod and co-host of the Mind Killer podcast.
Heck yeah, we did. And actually, we should probably put a 10 minutes preview out for people in the next week or two. But until we do that, know that is out there, and it is pretty darn good.
I plan to do more of those, just random questions I've got, and then talk to somebody who knows about them. I don't think they'd make for great whole episodes like this, especially because this one we didn't plan on going that long, but it ended up lasting just about an hour. But anyway, there'll be stuff like that on there, so do check it out. And thanks again to Matthew Baggins. I hear good things about those Bagginses.
Yeah, I hear sometimes they help save the entire freaking world. Thank you for helping save the world and save the podcast, and hope everyone else can be just like the awesome Bagginses of the world.
High five.
We will see you all in 2 weeks.
All right.
Bye.